Very similar to number 4. It says, for a certain type of car battery, the lifespan of a battery in the desert climates is normally distributed with a mean of 25.5 months and a standard deviation of 3.55 months. So this is your mean, this is your standard deviation. So we're going to start by labeling these. So I know I'm going to match 0 up with what our mu value is. To go to the right 3 standard deviations in the positive direction, I'm going to add the standard deviation of 3.55. So I have 29.05, add again, 32.6, and 36.15. Now to go in the opposite direction, take the average or mu of 25.5 and subtract the standard deviation. So 21.95, 18.4, and 14.85. Okay, so I've labeled 3 above and 3 below the mean. Find the z-score. So z-score is your data point minus your mu divided by standard deviation. So for this problem, we have a data point of 30.5. We have a mu value of 25.5 and a sigma value of 3.55. Okay, and although it doesn't say round to, I'm going to round here to the nearest hundredth. So it's approximately 1.41. Now, how do you know to round to the nearest tenth or the nearest hundredth? It should state in this problem what to round to. I should say it should have stated what to round to. Okay, so find the percentage of car batteries that are at least 23 months. When I look up here, I can see that 23 does not lie on one of these standard deviation values that are above or below the mean. In fact, it's in between. So I'm going to go back and use the calculator operations if you've forgotten. We're going to hit second bars and go to normal CDF. Remember, it's always lower bound, upper bound, mu, and sigma, in that order. So I'm going to write down those 4 places. It's lower bound, upper bound, mu, and sigma. Okay, so it says that find the percentage of car batteries with a lifespan of at least 23. So we're going 23 or greater. So my 23 is right about here, and I want 23 or greater. So 23 is going to be the smallest value, and then it continues to go to the right. And we learned about a normal distribution curve that it runs continuously from left to right. So as it goes to right, it goes to positive infinity. So I'm going to choose the number 999 to represent positive infinity. Your mu value is 25.5, and your sigma value for this problem is 3.55. Okay, let's plug it in. So second bars, normal CDF, and I'm plugging in 23, comma, 999, comma, 25.5, comma, 3.55, and parentheses. And then I'm going to round to the nearest tenth, so 75.9. As we can see up here, that would be very close to 75.9%. Okay. Part D says to find between the values of 22.5 and 26 months. So 22.5, somewhere in here again. 26, somewhere right here. So that's a pretty small little area, but it's in the middle of the normal distribution curve, which has the majority of the percentages. So the lower of the 2 numbers is 22.5. The upper of the 2 numbers is 26. Our mu value is 25.5, and sigma value is 3.55. Second bars, go to normal CDF, 22.5, 26, 25.5, and 3.55. Make sure I plugged everything in right. And this should have been 26. Okay, and I press enter. So 35.7, I'm gonna round to the nearest 10. 35.7%. Okay, next one is going to be find the percentage of car batteries that are at most 20 months. So we go up to 20 but not past. Up to 20, so 20 is right about here. Up to 20 but not past it. So I'm coming from the left, negative infinity, and going up to 20. Remember, we don't have a symbol in our calculator representing negative infinity, but we'll use the number negative 999. We're going up to 20 at most, but not past it. Mu value 25.5 and sigma value 3.55. Second bars, normal CDF, negative 999. Just as a reminder, the negative sign is below the 3 key. Then I'm typing in 20, 25.5, and 3.55. Rounding it, I'm going to say 6.1%. All right, part F. First, we're going to find a percentage, and then we'll go back and apply it to 950 car batteries. So we're going to go no longer, see, how many of these car batteries would you expect to last no longer than 30 months? So we're going up to 30, but not past. So 30 is right about here. Up to 30, but not past it. Up to 30, not past. So coming from negative infinity and going up to 30, similar to the last problem. Coming from negative infinity, going as far as 30, but not past it, lower bound, upper bound. Okay, our next value is going to be our mu value and our sigma value. Second bars, and I'm going to type in negative 999, 30, 25.5, and 3.55. Now I'm going to leave this on here. Let's see, and make sure I type this in right. Negative 999, 30, 25.5, and 3.55, okay? Oh, and I read this wrong. It says, how many would you expect to last longer than? And I thought it read up to. So, actually we're going to go in the opposite. So instead of going up to 30 but not 30, this actually said, how many can you expect to last longer? So if 30 is our starting point, we want to know, what can we expect to go beyond 30? So let's just go back down here and switch this. 30 is our low value. And we want to know how many expect to go 30 or longer. Changing this to our low value and this to our upper bound. Okay, I'm going to leave this on here, but you can see it's about 10.2%. So about 10.2%, writing it as a percentage, as a decimal, and then taking it times the amount of car batteries we have for this problem. So I'm going to leave it on there. Take it times 950, and this gives you how many you can expect to last longer than 30 months. So approximately 97 batteries out of the 950 could we expect to last longer than 30 months.